That sounds awesome. I'm stoked on that. Okay. There we go. And we should be live. Um, so yeah, how did that feel this morning? Seeing now, had you made any predictions before the, like we got the big news press release? The European Southern Observatory is going to release something from the Event Horizon Telescope about the Milky Way. What could it be?
Yes, what a mystery there.
Yeah,
So
yeah.
yeah, it's been long anticipated. Because the truth is, these are really hard observations, and there's really only a handful of black holes.
Earth, which is kind of amazing. Um, all right, well, let's get started then. Hi, everyone. I'm Fraser Cain. I'm the publisher of Universe Today. I've been a space and astronomy journalist for over 20 years, and I love to bring you behind the scenes for the kinds of discussions that I have with the researchers, the scientists, the people working on the science that we report for you. So today I am joined by a distinguished astronomy professor, Dr. Chris Impey. Chris, welcome to the show.
Yeah, it's good to be with you.
I mean, you have an incredible field of work, but why don't you give an introduction? Who are you? What do you do?
Yeah, I've been at the U of A, University of Arizona, for longer than I care to say, 35 years. I'm a Scot. I was born in Edinburgh, but if you've been to Scotland, there are not a lot of stars there. So, I was bound to leave after I got my PhD. So I've been in the U.S. for a long time.
It sounds like my home on the west coast of Canada. Like if I'm into
Oh,
astronomy, this is
right.
not
These are
astronomy, but
beautiful green places, but
yeah,
and the best place to be is a pub, but not at an observatory.
yeah, exactly.
So yeah, I've been here, and I sort of historically have worked on active galaxies or supermassive black holes in galaxies or evolution of galaxies, gravitational lensing, things like that. And more recently, I've layered in sort of education research, science literacy, teaching online, various things like that.
And we will definitely be talking about that now. And I mean, I highly recommend people. I put a link to Chris's bio. I mean, you've written how many books at this point?
I think nine.
9 books. You have hundreds of journal articles at this point, peer-reviewed journal articles. So you are qualified to pretty much talk about anything. And so, of the anything topics that you've done in the past, the one that I choose is a piece that you just recently wrote, which was for the conversation about, I guess, the current work underway to attempt to send a message out to extraterrestrial civilizations and the ethics and dangers involved. So can you talk about how this, I guess, how did you come to this topic specifically now?
Right. I mean, my research is more cosmology, but I've sort of been an honorary member of the astrobiology club for a while. I go to their conferences, I wear their silly hats and use their special handshake and so on. And I've written books about astrobiology just to learn about it. And so I ended up, for some reason, I can't remember how, I'm on the METI International Advisory Board. So METI is Messaging Extraterrestrial Intelligence. And it was just intriguing to me. So I followed. I mean, astrobiology obviously has a core thread, which is trying to find life beyond Earth. And that's either going to happen in the solar system or in looking at the atmospheres of exoplanets for alteration by microbes. The third line of astrobiology is the sort of hitting for the fences idea of SETI, which is searching for intelligent, artificial signals, radio or optical, from intelligent civilizations out there. And METI is a variant of SETI, where instead of passively searching and listening, you actually speak, and it's controversial, as
Mm-hmm.
you know.
And so I guess as one of the board members, what is the role that you've played in an advisory capacity?
I mean, the value of this board, which and the reason I've enjoyed being on it, is very interdisciplinary. So it's people all around the world. They're astronomers, of course, planetary scientists, but they're also sociologists, philosophers, and the conversations are very rich because this is a subject, the speculation of whether we're alone or not and what that might mean, that raises lots of ideas. So I've mostly just enjoyed the conversations. Now, of course, when the rubber meets the road and you actually start sending messages, then other things come into play. And I've watched that, and I have a little discomfort too. So I mean, we can talk about the
Yeah.
ethics because
Well, let's just start with the logistics first, and then we'll shift over to the ethics. So, what have been the attempts in the past to attempt to communicate with extraterrestrial civilizations?
right. I mean, they've been kind of artificial, almost cartoonish. I mean, the Arecibo message, the famous message beamed out by Arecibo in 1974 to a globular cluster that's 26,000 light years away, so 50,000 years to have a conversation. That's not very practical. And really, it was done not quite as a publicity stunt, but almost. So I wouldn't call that a serious attempt at communication. The nature of what the information you convey in some digital radio coded message is another issue. And after that, of course, we had the messages in a bottle. We had the plaques attached to the Pioneer spacecraft, 2 of them, and the records attached to the leg of the Voyager spacecraft, 2 of them. All have left the solar system. All will take, again, tens of thousands of years to be even in the vicinity of a nearby star. So it's hard to call those serious attempts at communication. And the stuff that's happening more recently that's in the news, it is more direct. It's using a telescope, a radio telescope in England to send a message to the TRAPPIST-1 system, where there are at least three habitable Earth-like planets, and it's only 39 light years away. And then talk of using the giant 500-meter radio dish in China to beam to probably thousands or hundreds of thousands of stars in next year or the year after.
This does have shades of the 3-body problem, but in real life. When you sort of, that's how the story started, was someone used a giant radio telescope in China to transmit a message and talk to aliens, and it all went horribly wrong.
Right.
So then, what kind of message? Like, what is the best? Like say we know, or we suspect there's a civilization at Alpha Centauri, but we haven't made contact with them, and we want to send a message to them with the highest possibility of them both receiving it and comprehending it. What is the best way to go about this?
It's controversial. It's argumentative at every level because, of course, we are products of our culture, our language, and that's hugely specific. I mean, even if I imagine that there's life in the universe, and even the microbial basis might be this roughly the same as our biochemistry, it's really hard to imagine that advanced life forms would share our characteristics at any level. So existence is one thing, but communication, that's a whole different beast. So we sort of do what we can do. And we do kind of the obvious thing, which is binary coded messages that represent little pictograms. It's almost like, we've been doing cave art for tens of thousands of years, and petroglyphs where I live in Arizona. And these are just modern kind of high-tech versions of petroglyphs sent out into space in a sort of sequential form, binary coded in radio pulses.
And what is like the best wavelength they think to send?
Well, going back to the beginnings of SETI in 1959 was Project Ozma. They've always, this is from Barney Oliver, who's one of the founders of SETI, working for NASA. The idea of the water hole, the idea that there's a region of radio waves, centimeter wavelengths, where the universe is fairly transparent, and so they can penetrate even through to the center of our galaxy or through dust and gas, where the energy cost of creating the waves is quite low. And then you have the hydroxyl transitions in this region of the fundamental molecule of life, water. So that was where the idea of the water hole came from, and those are the wavelengths that have been mostly used.
And that's the wavelength that you would use, but what can we do to make it? Because my understanding is that there are certain wavelengths that if we saw them, they would be unambiguous that they had to be coming from an intelligent civilization. There's no way to produce these signals through nature.
Right. I mean, radio waves are good for that in general, because stars are quiet in radio waves, and so the universe is quiet in radio waves. Now, SETI has been conducted now at optical wavelengths, looking for pulse lasers, because we actually have powerful enough lasers that in a nanosecond we can outshine the sun. So seen from afar, if you were staring at a sun-like star, and chopping the light up a billion times a second, you might see a civilization beaming a laser out. But the universe is horribly noisy and lit up with light, so radio waves are the best way to go. I think that logic is pretty good. But that's not to say that it's silent. So there are radio emission from the Milky Way, of course, at all sorts of wavelengths. So there's no perfectly clean experiment. And then if you just want to jump out of the box, you'd say, well, how retro to just be using radio transmitters and lasers. That's so 20th century, really.
Right.
Surely an advanced civilization is going to be using gravitational waves or neutrinos or something much more high tech and advanced.
Well, I mean, that was good. So go ahead and debunk that. I mean, why? I mean, I guess, like, obviously, like, we can't generate neutrinos at that kind of capability, right, and we can't generate gravitational waves unless we've got black holes kicking around that we're willing to smash together.
But that's now, right? So the problem with SETI is this moving arc of time. It also references the indomitable spirit of people like Jill Tarter and Seth Shostak. After 60 years of the great silence, if I've been doing a scientific experiment for decades without success, I'd kind of give up. I'd move on, do something else. And they're not discouraged. And part of it is because of Moore's law and capabilities of transmitters and receivers, their capabilities are increasing exponentially. And they just say, well, the experiment's only just starting to get interesting now because our capabilities are so good. And so it's the same with the messaging. You do what you can with the technology you have. Seth Shostak has a nice, witty retort for this. Well, why don't you just wait till you have better technology? He said, well, Christopher Columbus, when he went to the Queen, she could have said, well, wait a few hundred years and you can get to America in a jumbo jet in 5 hours. No, you go with what you have. You go in the ship because that's what you have. So we're just doing what we can. And of course, it's very hard to look at that and to derive any plausible argument of the probability of success or whether even it's a reasonable strategy. So, it's necessarily subject to criticism because of that.
I mean, there's like I guess just like an expectation that if they are an advanced civilization, they will be aware of the downgraded technology that various starter civilizations might be attempting to use, and would still have a listening dish set up to receive whatever version. And maybe they will. They're going to have they'll have the radio dish set up. They'll have the laser, I guess the telescope set up looking. They'll have their neutrino detector and the gravitational wave detector. And then the real communication system, the sublight transducer that they all use because that's the best way to communicate.
Right. And that's reasonable. But, as this whole field is suffused with anthropocentric thinking and, culturally and technological specific assumptions. And you could easily say, since statistically, it is likely that we're not the first or the most advanced civilization in the galaxy, if they exist at all. And that difference, could be dramatic. What would we have to say to humans 50,000 years ago? I mean, they would be just sort of museum or zoo creatures to us. They have nothing to teach us. And so a really advanced civilization, I suspect we're just not very interesting to them. I don't think it's dangerous, like they're going to eat us or destroy us necessarily, but I don't know. But I also think that we're not necessarily interesting. So they might not even be caring about us or looking for creatures of our caliber, which we're always very impressed with ourselves, but I don't think we should be.
Yeah, but I don't think that's true. I mean, I think if we could have a conversation with someone 50,000 years ago, it would be fascinating. It would be a wonderful piece of history. It would tell us a tremendous amount about our place as a society and how we got to where we are. And there's all kinds of interest. And I even think, like, people say, like, oh, well, maybe we couldn't even recognize them. But, like, an ant can recognize me and bite me. Right. So he knows I'm here. We can't have a conversation, but yeah.
Early humans, I agree. That was a bad example. Octopus might be a better example because they're just, I think intelligent, manifestly intelligent and incomprehensible really to us at some level. But they're still part of our tree of life. And we're talking about an entity out there that is not part of our tree of life, that has been sculpted by evolution in really unforeseeable ways. And so, the level, when people talk about aliens, the operative word is alien as an adjective. How alien could an alien be? And I think the answer is radically, dramatically, unrecognizably alien.
Yeah. I mean, probably, but also, I mean, they do live in the universe. I mean, we see convergent evolution here on Earth with eyes evolving multiple times, wings evolving multiple times, tool use evolving multiple times. And so it feels like if you're stuck in the universe with the laws of physics and chemistry, etc., as we understand it, then it's even like evolution through natural selection. You can imagine that imprinting a certain kind of, I don't know, societal implication that, that eat or be eaten, I guess, right?
Yeah. Right. And it's still just one genetic experiment, one biological experiment. So while I do agree that there's likely to be some envelope of universal biochemistry because the ingredients are similar and the molecule of water is available and so on, as soon as you go very far down that road, it becomes extremely unpredictable what you're going to get. And then that transition from life itself to intelligence to sentience to technology, those are remarkable transitions that need not have occurred at all on the Earth. It took quite a long time to do so. And then, of course, there are the people who say, well, we're heading ourselves towards a membrane to becoming post-biological. And as soon as you become a purely computational civilization or entity, again, all bets are off. That could manifest and progress and transmit and in so many different ways that are very hard to anticipate.
All right. So we've talked about sort of like engineering wise, the best way to send the signal that we think is going to get received. And then for the content of the signal, as you said, like that first version was very cartoony. What is the modern thinking of what is the best way to construct a signal that it will have the best chance of being able to begin a dialogue with another civilization?
It's not really changed that much. So the message, the paper that's out there recently called The Beacon in the Galaxy, that's the message that hypothetically might be sent by the 500-meter telescope in China. Yeah. It's just a slightly upgraded version of the Arecibo message, has some of the same elements. It's actually a kind of modest message. I think it's 150 kilobits of information, which isn't very much. You think, come on, that's a tiny fraction of a DVD's worth. Can't we do a little better than that? Can't we be more ambitious? So, that's a slightly, to me, disappointing thing that hasn't really changed that much. Now, there have been linguists and philosophers who put papers out there. Lingua cosmica was an idea. There were people who were deciding this is how you might send or devise a coded language that really just represents logic and mathematics and conveys that information or the fact that we understand that information rather than trying to make little pictograms and assume a visual sense or assume some cultural recognition at some level. So, there have been in the literature small attempts to do a more sort of what I might think of as profound or universal attempt or model for communication, but that's not what the real experiments have been.
Yeah, I loved like Arrival. I'm sure you've seen the movie as just a really wonderful investigation into attempting to communicate with an alien civilization with a utterly different method of speaking, and yet both are willing participants attempting to communicate and attempting to help understand each other. And it was such a wonderful investigation into just like what would be the thought process of a scientist attempting to both understand but also to be able to communicate with these alien beings who are very alien, and yet I suspect not alien enough, right? Like it's almost feel like if we can imagine it, then it's more alien than we can understand. So math versus pictogram. Do you come down on one side of this, whether you like a pictogram over math?
There's usually components of math in the messages. I think it's like a padding, or it's a framing sequence for the beacon in the galaxy message is a sequence of prime numbers.
Yeah.
You know, and that goes back to contact and so on. So and so with math, it's tricky because if you convey something that's essentially trite, you know, you haven't really conveyed the subtlety of your level of knowledge. Conveying something that isn't trite mathematically or logically is much more challenging, and you actually need a whole edifice of conversion of concept to code that is not trivial to do at all, and people have argued about it. So, but I mean, I would tend to prefer that type of message because I just think it's more universal potentially and more sophisticated and less anthropocentric.
Let's now deal with the elephant in the room, which is the ethics of this. And there are some people in the chat who are losing their minds. And don't worry, we're now going to have the conversation about the ethics. Is it right? What are the risks? Is this crazy? Should we be quiet?
Right. The dark forest? I guess, right. So we're alluding to, you know, a classic recent science fiction, which, you know, puts a pretty dark spin on this and just says it's a sort of dog-eat-dog world out there, and you would not betray your existence in the dark forest because you will be preyed upon. So clearly, there could be risks, and the risks, you can't assign a number to the risks. You know, you can't quantify the risks. And that's a tricky situation. And I think that the levels of ethical issue with this are, you know, just the binary question, should you do it at all?
Right.
And then if you do decide to do it, is there a safer way to do it? Like only sending information to civilizations that are tens of thousands of light years away, so, you know, nothing is going to happen soon. Or, and then who's doing this and who elected them? I mean, I'm on this international advisory group and I wasn't elected to it, and it's a small group of people. And METI itself is really only a few dozen researchers around the world. So, you know, the UN wasn't asked or consulted. There's no group within the UN who would do this kind of work anyway. There is an overarching space policy and advisory group in the UN that could take this on potentially. But that's part of the ethical issue as well. I mean, nobody asked this group to do it or gave them permission to speak for the Earth. If there are risks attached, then, you know, why should they do that? As you know, Stephen Hawking, before he died, was quite vocal about that. He didn't think we should do it.
Yeah. So then, I guess, what is the risk? What was Hawking worried about?
He was essentially worried about the fact that if we betray our existence, he thought there was some reasonable probability that advanced civilizations would need resources or be malign or both, and that you know, we would be viewed as a resource for them rather than as partners or you know, people who they could collaborate with or whatever. And he just thought that he knew you couldn't quantify that risk, but he thought it was real enough that you should just be cautious and just not do that experiment. If you had a choice, you just wouldn't do the experiment. There's nothing wrong with listening. We can keep listening, and as we are. So why do the METI thing at all? Yeah.
So the argument to that, and the one that I bring on the channel quite a bit, is that we're in the process of launching, or I guess we have launched James Webb. It is about to come online, and theoretically, especially with, say, the TRAPPIST-1 system, it's going to be capable of detecting, sensing the atmospheres, and maybe if we get a very clear biosignature, then maybe we could get a sense if there's an extraterrestrial civilization there through their pollution. It's like probably just outside the scope of James Webb. But you can imagine the Super James Webb, the James Webb 2, or the Hubble 2 in the three-body problem, or more significantly, say, the solar gravitational lens proposed that's in work by NASA that would give you a megapixel image of an exoplanet around another star. Earth itself is giving off an extremely unusual signal to the universe that there is life here. It has been doing so for 500 million years. Our technology has been doing this for hundreds of years. You know, an alien civilization can tell that we have chlorofluorocarbons in the atmosphere. And so it feels like if we are 100 years away from being able to image every exoplanet within a few thousand light years at megapixel resolution, wouldn't advanced civilizations capable of crossing the gulf between stars be at the same place? Don't they already know we're here?
I certainly, they could and probably should know we're here if they have those kind of capabilities. The imaging of exoplanets and that one project you talked about, the gravitational lensing of the sun, very clever idea. Outside of that, it's an exceptionally challenging job for our technology or even a projection of it. The project we haven't mentioned, of course, is Breakthrough Starshot, which is going to hope, in a couple of generations, send nanobots to the Proxima Centauri system, where there are a couple of bets for Earth-like planets. So that's the more direct approach. I don't know. They have many technical challenges that they haven't solved, but they put them all in view and they're working, resolutely. I'm sure they've had 100 million from Yuri Milner. They're going to need a few orders of magnitude more than that to actually do that project. But that's a different approach. But yes, to answer your question, I agree that of not that vastly superior technology to ours would make it pretty obvious to know that we exist or something like us exist. Although I was on NPR a long time ago rebutting the idea that our inadvertent, bubble of radio and TV signals is alerting people to our existence because they've now spread over 100 light years and thousands, millions of stars. I just whipped out the back of the envelope and showed that those transmissions are below the microwave background hum almost as they leave the solar system. So that's
right.
Essentially noise, undetectable noise.
Yeah, if it's not directed, but also I've heard that when the square kilometer array comes online by 2030, it would be able to detect the air traffic control systems out to a distance of about 100 light years. Yeah.
And the SETI people are, happy to point out that with projecting their capabilities, maybe 20 years in the future, we will have had the technology to detect, Arecibo. Arecibo doesn't exist anymore, but Arecibo transmitter analogs or pulse laser equivalents of ours at a distance that includes tens of millions of stars. So if those technologies do not exist or are not being actively used, then that null result is going to start to mean something in 20 years.
Yeah, I mean, if we did build a super version, like LUVOIR is a good example, or maybe a super LUVOIR, like imagine Starship is flying and now we've got a 50-meter telescope, space telescope, capable of resolving multiple pixels for Earth-sized worlds around other star systems out to a very significant volume of space. You'll get to a point where you will know quite definitively that whether or not there's life in the universe, because you can just through if you've sampled 10,000 star systems and you don't see one example of any biosignatures out there, then you can just extrapolate that to the rest of the universe and say we are alone in the universe.
Right. And that's important. That's an important, comment about the state of astrobiology and where it's headed. That, having been full of promise and excitement and anticipation for decades, the rubber is now meeting the road. We have experiments, with the next generation of large telescopes, starting with a little bit with James Webb and so on, that are going to answer the question, within probably 10 or 15 years, for sure.
And so do you think, like, if we did wait the 10, 15, 50 years, 100 years, get to the point that we are scanning vast swaths of the Milky Way, there's no need to communicate because we already know the answer?
Right. So, again, you will not deter the SETI faithful because they just want to keep doing the experiment with their yearly increasing capabilities, just, in case they get lucky. They're buying a lottery ticket and you never know what's going to happen. But yes, astronomy is going to get there, in hopefully in due course, and we'll know the answer. And as you know how many different answers there are to Fermi's question. We could be pretty much alone. That's certainly possible.
Yeah. But then I wonder about the other side of this. Like, what about the opportunity, the lost opportunity? That, that if you're too shy to reach out and speak to somebody when you're waiting in a line for a movie or whatever, you might lose a chance to make a friend. Right. And so absolutely the cautious thing to do is to keep quiet, to in fact shift over all of our electromagnetic transmissions to fiber optics so that we're not broadcasting our existence, to put up monstrous space structures that will block our transiting planet. We'll fire a laser to compensate for the transit of Earth to various star systems that could be watching us, to hide. But like that chance of making a lifelong friend, there is also the risk that we don't make contact with other civilizations and share knowledge, which would be, again, if you could have an open dialogue with another civilization, what value would that be for humanity?
Right. So you're raising the other important question that's associated with this topic, which is, why do we want to communicate? I don't know whether we should or whether it's ethical, but why do we want to? Are we doing it to be boastful? Well, we always are being a little boastful because we're quite full of ourselves. Are we doing it to get help because we're kind of screwing up? We're kind of messing up our planet. We're a tribal, warlike set of cultures that are not doing too well. We're doing well in some metrics, and in other metrics not doing well at all. Are we looking for help, for salvation, for redemption? Who knows? What is our motivation really for this? I mean, I'm not.
So I guess
question,
no, I know, but do you feel like that opportunity lost to set up a dialogue with another civilization that will have a second independent view of existence has value?
Well, sure, because I do believe the sort of timing argument that if contact is made, it's almost certain, as we're on the cusp of our little adolescence in the galaxy and barely having left the planet, it is likely that it will be a much more advanced, long-lived civilization. And so, yes, they will have learned some things, had learned some lessons, been through some transitions or stages that we haven't yet. And so there would be something to learn. Yes, that's useful. I mean, it always gets this slightly religious overlay because the aliens in popular culture have been posited either as destructive, this back to Stephen Hawking, they're either posited as advanced, malign, and destructive, Independence Day, or they're posited as beneficence, salvation, E.T. as the Christ analog, etc. So we have these models in the popular culture that I think suffuse even the scientific discussion a little bit.
Yeah. And we always say that we are like anthropomorphizing, or like, I don't know, it's like human-centric when we think about what aliens are going to be like, what civilizations are going to be like, and when we think that they're going to be dangerous. But it could be that fallacy is playing into every possibility of what the aliens are like. We can only imagine them in the way that we can understand. Like whenever you watch Star Trek or Star Wars or read a science fiction book, you're essentially learning about people in rubber suits, right? It is never truly aliens, because if we can imagine it, it's kind of not alien enough.
Right. It's just that, yes, there's rubber suits and bad skin conditions. That's as alien or scary as it gets.
Yeah.
So yes, that anthropocentric, almost inevitably anthropocentric thinking suffuses the subject, but it still doesn't amount to an argument of doing it or not doing it. I think the part that we talked about earlier, the who should do this, who speaks for Earth, that's an important question.
Yeah, absolutely.
We're facing as a global culture, we have a set of problems now. We used to operate as sort of city-states or countries competing with each other for resources and so on. And now we're framed by some, larger issues like climate change, which only have a solution if we're operating as a planet. And this is a small, almost trivial example of operating as a planetary species to decide to communicate or whether to leave Earth, for example, and establish off-Earth colonies that become an independent offshoot of humanity. That's something we're also facing now as the private space program finally delivers on its goals.
How do you think this will play out in
With
with this specific experiment, with these attempts to design a message? Will they send their message? What do you think is going to happen?
Yeah, I think, at some level, Medi, because it's such a small, fringy almost activity, I mean, it's under the radar, really. And so it's not going to cause consternation particularly. And I think people will just do it. I mean, and of course, that's for some members of the public who have a slightly jaundiced view of science and scientists, that's their rap against science anyway, that scientists are very often asking, how do I do X, Y, or Z, not whether I should do X, Y, or Z. And so I think, yeah, people will just do it.
And so then do you think that, say, sending a message to, like sending a probe, like going with, say, the breakthrough starshot method and sending a probe to another star system to scout it out is a safer way to understand our place in the universe? I mean, there's risks with that too, as you hurl a projectile at another star system. Like, do we forever hide? I guess is what I'm asking.
Maybe fewer risks, perhaps, with sending nanobots that filter their way down through the atmospheres of exoplanets that might have life on them. And of course, the reverse issue is also relevant, because the people who are engaged in SETI are also aware that the possibility of alien artifacts still exists, and that they might indeed be very either unrecognizable or miniaturized at a level that we simply wouldn't know or notice. So, and then we're subject to the zoo hypothesis and so on.
Yeah. I mean, we definitely haven't explored the solar system for von Neumann probe factories yet. So that should be on our to-do list.
No, that's right. So we're it's so early. Astrobiology's, appetite is bigger than its stomach. I mean, it's even the first experiments to find biomarkers in the atmospheres of Earth-like exoplanets. Those are really difficult experiments, and the data is going to be kind of ugly, messy, noisy, and ambiguous, because there's no smoking gun biomarker.
Yeah.
And you can get, for example, there's disconcerting papers about how much oxygen you can get abiotically in the atmosphere of an Earth-like planet. So, it's the interpretation is going to be kind of interesting. I mean, maybe the solar system looking for extant or fossilized life approach is going to take a couple of decades, but that may be more convincing, especially if you find a second genesis in one star system.
Yeah. Then that makes the great filter argument start to get a little more terrifying. But I think that we have had our understanding of this whole concept sort of on the one hand informed by history, which has not gone well for those who have been visited by more technological superior. So we imagine ourselves as the lessers in technologically, and then you have science fiction, which is throwing this all into overdrive. How could we even possibly unravel our personal, and I guess it's back to that idea, how could we unravel that to get back to what is a sort of more rational, ethical answer to this?
I really don't think we're able to. I think it's not in our DNA per se, but it's our cultural embedding and that dichotomy that we talked about already, that sort of warring utopian versus the dystopian ideas of what's out there, which are, those are our inner selves warring all the time. That's human history too. I don't really think we can jump outside that very well. And the scientists, of course, are no more able to jump outside it than anyone is.
Yeah. Yeah, so I guess we'll put a pin in that. We'll let people figure that out. We'll wait for the solar gravitational lens. In any case, any message that gets sent out, we're looking at hundreds, if not thousands, of years for it to receive an answer, which could come in the form of a space armada coming to steal our water. But still,
Right.
oh,
And
so
we're,
what?
and we're famously impatient. I mean, human culture, we work on an election cycle or whatever. So
Yeah,
the clock of the long now is the only human technology project I'm aware of that's taking time frames of thousands of years. Most of our experiments, scientific or otherwise, have a very short time frame.
the Voyager records were designed to last 1 billion years.
Yeah.
So you've got that, and there's like a sign people are trying to figure out to warn people about nuclear waste that could last for hundreds of thousands of years. And how do you send a message when maybe language has changed, maybe civilization has gone through cycles, and you're still like, this is a bad place, don't go anywhere near here. So it is interesting. So the so I'd like to shift gears then and talk about your work in helping people detect bad science on the internet. What's this about?
Sure. So, as you well know, in your media world, misinformation is rife. It's growing. It's been obviously heavily a problem in the health sector, but it's a problem more generally. The scientific misinformation on whatever subject you want to talk about is just growing exponentially. And of course, it's turbocharged by social networks. So you can't really fight it in any way. So we were trying to do a sort of technology. It's not a solution necessarily, but it's some armament on the side of information versus misinformation. And basically, the project is to train neural nets, use machine learning methods, which have now matured very rapidly with the language models developed by Google and so on. That are behind your voice assistant and many other technologies. To just essentially look at corpuses of information. You train them by hand selecting by smart students who use undergrads or grad students, like 100 articles on 200 articles on climate change, legitimate articles, and these are popular, not technical. So on the internet, blogs, newspaper articles, and then an equal number of misinformation articles, climate science denial or whatever. Or if it was an evolution example, it would be natural selection or evolution versus creationism or intelligent design or whatever. And so you train the neural net on these curated sets of articles, and then you unleash it on hundreds of thousands of articles on those topics drawn from Common Crawl, the entire internet that you can download at your will. And our little test bed has shown that we can be about 95% accurate in distinguishing the real from the unreal, or the misinformation or pseudoscience from the real stuff. And a trained neural net on one topic doesn't necessarily translate to another topic. There may not be one machine learning method that applies across all domains of science, but at least it seems interesting enough. At some level, it's remarkable that it works because these language models, they don't have any grammar. They're not looking at meaning. They're literally looking at grainy word-to-word patterns, very subtle patterns in these bodies of text. So there's always a black box element where I'm amazed that it works at all, But it does seem to work. And anyway, to cut to the chase, in about a year, our deliverables or our manifestations of this would be a browser extension, which just sits there in the background. It's smart enough to figure out if you're on a web page that's science versus sports or news or cooking or something. And it only kicks in if you're looking at ostensibly a science page. And then it uses these trained neural nets to give you a Bayesian statistic probability that what you're looking at is good or bad, and give you a little color-coded dial, green to red. And if you're on a bad page, it will hopefully point you to articles also that we curate, giving you the better information. So browser extension. And then to have a more social element, we'll do a smartphone app. And that'll let us gamify it. So you can compete with your friends and your relatives and your colleagues to classify real and fake articles that get popped up and unattributed. And we just compete on that. And maybe when we have enough people doing that, we can crowdsource the training of the neural nets to a different level. So those are the two ways we would deliver this, probably about a year from now.
And I wonder, like, I sort of imagine kind of three things. There's like some bad faith material that's being put out there to purposefully muddy the water, to support paid actors, you know, say the lobbyists that are supporting climate change denial articles. Like, they're really trying to cherry pick and do a bad job. And then you've got kind of mild incompetence, where people aren't great at understanding that this study didn't have enough, didn't have enough of a cross section, wasn't a wide enough, wasn't done very well, and so that's tricky. I can't imagine how you'd be able to spot that. And then you've got stuff that is, I guess, good, where people understand the scientific method, understand and are able to use the right coulds and shoulds in their article to help properly place this. I hope that's where we are with the universe today. How well do you think you can go after that stuff in the middle?
That we will test probably best with the climate change body of information. But yes, you're right. I mean, there's a sort of layer of this method that involves looking for claim evidence pairs. This is another thing that's been done by big internet companies and with large bodies of data. So basically, the neural nets can also be trained to identify assertions of fact or claims or supposedly factual statements, and then look elsewhere in the body of that article or elsewhere on the internet for evidence to support those claims. And so if it doesn't check out in that way, then that immediately becomes a downgraded. So if you're using sneaky arguments, you're still going to be caught by that claim evidence connection that has to be made, because the evidence really won't support your claim, either uniquely or at all, or there's no evidence given to support the claim at all, or you're cherry picking the data to make a particular argument. I mean, there are subtleties there, but one of our first test beds was on climate change, and it seemed to work quite well because we were picking some of the quite subtle climate change denial articles to put in the fake pile.
There was a science fiction story that I read, and I forget where I had seen it, but the gist being that in the future, because the AI filters will be so good at attempting to pick out misinformation, the misinformation attempts will have to end up being more and more subtle. It's going to be this arms race. And so you will be reading a science article that is 99% correct, but there are just a couple of words in there designed to give you like a little bit of a influence one way or the other, and hopefully that will evade your personalized filters, right?
No, I agree. It is an evolutionary arms race. Of course, if you get to that point, then you might just say, as far as general public literacy goes, well, if this person's reading something that's 99% correct, I'm pretty happy with that. So
yeah,
I won't mind a little bit of it. I mean, some of the as you know, the misinformation can be so grotesque and so egregious that the bar is still fairly low, because a lot of the stuff out there is just crazily wrong, manifestly wrong, but written with a straight face and with supposedly scientific words and supposedly with a logical structure. And that stuff we can pick up easily.
Yeah, it's amazing how much a lot of that dropped off once the Russian-Ukrainian war began, and a lot of outlets were blocked in Russia.
Now the thing that has to be said, of course, is that none of this can mitigate willfulness on the part of people to believe conspiracy theories or be in information bubbles where essentially nothing can penetrate. So if you're in one of these bubbles, hermetically sealed or self-consistently constructed, then no, we can't really do anything about that.
Yeah. I always find it really interesting. Like we're in this time where all of humanity is coming together for the first time. in one space or in a few spaces, Facebook, Twitter, etc. But essentially, like even right now on the in my chat, people are are interacting in an uncivil manner, and you don't have to watch it. I'm noticing it, and I'm disappointed in you, chatters. But that is in theory a good thing. That all of humanity should have the ability to talk to each other and be able to come together and directly connect, as opposed to having to go through multiple levels of gatekeepers. And yet it has caused this sort of planet-wide freakout, because now for the first time we're having these conversations in real time with each other, no holds barred. And it is like a novel virus, pardon the, the coronavirus timing of this, but we are experiencing this, and we don't have the antibodies yet built up for us to be able to navigate these kinds of conversations, to shun the bad actors and allow the good actors to come into our conversations and in our lives. And so I like the approach that you're doing, where it's a personalized filter. Like if you want to live in a more science oriented version of the internet, you can.
Right. I mean, and I like your thought, because it's a good thought, that there is a sort of universal polis or public space where people can come in and mingle and share ideas, and it's broad and it encompasses billions of people potentially. That's the ideal. I'm not sure in practice if that's what happens, because the research on social media, of course, is showing that they can accentuate the polarization or the sort of the information bubble, sort of whatever. So the capability, the potential for that common dialogue across cultures and countries and languages is there for sure, but I'm not sure that's what people gravitate towards necessarily.
Yeah. But I think we have to. Like we can't, it's unsustainable. I mean, people are talking about how Elon Musk is hoping to take over Twitter, and they're worried that he's going to make it worse by opening up the floodgates and letting people talk. I don't think it can be made worse. Like Twitter is right at the line of as worse as it could possibly be in terms of a bad time in interacting with other human beings.
Right.
And so if it was made any worse, it would just be unusable and people would leave it, like 4chan or,
Right.
The trolls would just be stuck talking to each other.
No, I mean, the internet is a chaotic mess, of course. But I mean, the argument that it is doing your more sort of noble thing is the fact that autocratic governments around the world are really trying to shut it down. I mean, they're trying to reverse, decades of progress towards some, generally democratizing ideal of everyone having access to information. Doesn't matter where you live, doesn't matter how rich or poor you are, and so on.
Yeah.
And that some of that was delivered. Wikipedia
Yep.
exists. There's some really good things from the last few decades.
Yeah. So one last question. What is your answer to the Fermi paradox?
They don't care.
That's so we are not alone in the universe,
Right.
but they don't care about us.
Yeah, and that's really it's a statement indirectly about the technological mismatch that's most likely, I think.
Yeah. But they also then don't want our stuff. They don't need our atoms or our energy.
Yeah, I'd say they don't care, closely followed by their unrecognizable / inscrutable.
So does that almost mean that they don't exist?
Yeah, operationally means they might not exist.
But they're functionally, like, because they're not, it's not like they're competing with us for resources. They're not competing with us for attention. They might as well not exist.
That's right.
Yeah.
That's right. And then that begs the question of, why bother doing these experiments? If you logically decide that's the
Right.
most likely outcome or situation, then why would you do that?
Yeah.
You should take your time and do other things.
Well, because you could be wrong.
That's right.
Yeah, that's why. Well, Chris, it was absolutely fascinating. If people want to follow your work, what's the best place to do it?
Well, that's a good question. I mean, I'm on Twitter and LinkedIn and
I'm
whatever.
sorry.
Yeah. But those are bad places, I know. I mean, mostly I just write sort of popular articles for the
Yeah.
conversation and places like that. So I just pop up on the internet here and there. I don't have a blog, and I don't have a sort of steady presence like you do. But sometimes that's for good reason. Having written an article on UFOs for the conversation and dealt with, a firestorm,
Yeah.
1,000 comments, and I thought, I don't want to go there. Sometimes being a public astronomer, a public science communicator, as you know, it has its downsides.
And a book? What's your most recent book that people should definitely read?
I mean, since black holes are in the news, of course, Einstein's Monsters, I wrote a couple of years ago about black holes. And the one that's coming out next year from MIT Press is on exoplanets, Worlds Without End.
Wonderful.
Yeah.
It is exciting. It's an exciting time, and it's great to be able to even have these conversations. So I really appreciate you coming and chatting with me about it. I don't think we solved it. So let me know if anyone.
Very well.
Yeah, let me know if someone does solve it.
Okay. Thanks.
All right.
Fred.
All right.
It's fun.
Take care, Chris.
Bye.